Just as we can describe an algorithm in terms of time complexity, we can also describe the space complexity of an algorithm. How much space does the algorithm need as a function of n? And just like how we used big O, big omega, and big theta notation, we can use the same notations with space complexity, though we'll typically use big O notation because we usually want an upper bound. So let's take a simple example. Let's say that I have a linked list structure where I have maybe a bunch of nodes that have some integers in them. And let's say this is a singly linked list. And let's say I have some pointer to the front and some pointer to the back. Unlike time complexity, which is really entirely language agnostic, space complexity, you do sometimes have to take into account the details of the specific language. For example, if I were to implement this in C++, I could take into account the fact that this head pointer has some fixed size, usually it would be 4 bytes. I could imagine that my node class would have some next pointer as well, that would be 4 bytes. I would expect I have some data value that has some number of bytes. Maybe in this case, if it's an int, maybe it would also be 4 bytes. And this tail pointer would also be 4 bytes. So I have some notion of how many different variables I will need inside of my objects, and I have a notion of how big those variables will need to be. Generally speaking, if we summarize to the level of big O notation, it should still be fairly language agnostic. So for example, even though in C++ I had all these different specific sizes, even in C++, if I'm looking at big O, well, however many bytes it takes me to store one node, I will roughly have that many bytes. So let's say it takes me k bytes to store a single node. And if I have n nodes, it would take me roughly k times n bytes overall to represent them, where k is some constant denoting the size of a given node. And I'll have these two pointers, but regardless of what size my array is, however big these are, I just have one of the head pointers and one of the tail pointers. So if I have a million nodes, I still only have one head and one tail pointer. So these scale constantly. So if the size per node is a constant, and these are constants, the overall space complexity of a linked list with n elements would be big O of n, right? Really, the function would be some constant that I don't know what k actually is, but some constant per node times n plus these two pointers, however big they are. So let's say those are also like, maybe I'll call this c for a different constant. Maybe k is the size of a node, and maybe c is the size of either of these two pointers. Still in big O, this term has n to the 0, so I would drop it. And this is a constant, so I would drop it, getting big O of n. So again, just like with time complexity, I can use big O to describe space complexity. How does the space consumption of a given algorithm scale as the input size grows?